Google recommends using probabilistic methods. They emphasize both differential privacy and k-anonymity. And I think that probabilistic methods are probably the way to go. So just a few words about differential privacy, which I think is a very exciting alternative. And what's differential privacy about is about introducing some level of noise to the data that it still would be helpful when analyzing the data on an aggregate level, but it would allow for plausible deniability on the individual level. So those are a lot of big words. Let's try and have an example. Let's assume that I'm trying to have like a survey or a poll regarding who would win the US election. Would it be Trump or Biden? I could ask you directly, like, Beth, who are you going to vote for? If I were to do so and also record that data in my database, you might be facing a problem if that database is going to leak. One way to protect against that, aside from protecting your database with a firewall, etc., is not to record your answer as is, but to ask you, Beth, we're going to vote for. Now, wait a second, flip a coin. If it turns out heads, then tell me the true answer. If it turns out to be tails, then flip it again. And then heads means Trump, tails means Biden. And then I'm going to record that answer. We have two main things that we get out of it. First of all, if I'm going to analyze the data, that data is 75% accurate because in 75% of the cases, I have your true preferences. So we introduced 25% of noise. We can still be relatively certain if I have a large enough sample who's going to win the election. And if the database leaks and someone knocks on your door and says, Beth, why did you vote for Trump or Biden? You'll have plausible deniability. You can say, I didn't vote for whomever. It was random noise. You got it all wrong. So we kind of win from both worlds. And I think this kind of approach works very well when we have a large data set, which fortunately, usually in adtech, we do.